Welcome everyone. This is Math 100 Section 2.4, Multiplying Fractions and Mixed Numbers. Please start with a warm-up. We're going to convert 28 thirds to a mixed number. So we take the numerator, divide by the denominator. So 3 goes into 28 9 times. 3 times 9 is 27, subtracting get 1. So we got 9 remainder 1, so 9 is the whole number. 1 goes on top. Denominator stays a 3. 9 and 1/3. Now this one we're going to change to an improper fraction. 13 times 8. That's 104. And then we're going to add 10 to it. So 114 over same denominator. Remember, no matter which way we go, the denominator stays the same. Unless we need to reduce. So as an introduction, a chef for a catering business wants to try out a new recipe. It's called funfetti cake for a wedding reception. And they've got 48 guests plus the bride and groom, so 50 people altogether. Now, funfetti cake, recipe for 4 servings, and some of the ingredients, we didn't list them all, but some of them are 2 1/4 cups flour, 4 eggs, and 3/4 cups rainbow sprinkles. Now first the chef wants to try out a batch of the recipe to see if it's acceptable. So the chef is going to make a quarter recipe. And then, if the chef likes the cake, the recipe will be used for the wedding reception. Then the chef is going to have to make enough for 50 people. And we're going to learn the mathematical operation to figure out how much of each ingredient we need for both the 1 serving batch and the 50 serving batch. In order to do that, we're going to need to be multiplying fractions. So the rule for multiplying fractions is multiply straight across on the top, straight across on the bottom. Do not cross multiply. That's only used when we have 2 fractions set equal to each other. And we'll see more of that in the chapter on proportions. But for right now, when we multiply straight across. A times C is AC, B times D, BD. So for the first example, multiplying across, 2 times 3 gives us 6 on top, 7 times 5, 30, 5 on the bottom. Your turn, number 1. All right, same result on top. 3 times 2 gives us 6. 11 times 5, 55. Neither of those can be reduced. Sometimes they will be able to be reduced. All right, 2 times 3 is 6. 7 times 4 is 28. So this is the multiply and then reduce method. We're going to multiply first, reduce the answer. So 6 then can be divided by 2, and 28 can be divided by 2, giving us 3 14ths. Your turn, number 2. We're going to multiply straight across. 4 times 3 is 12. 5 times 8 is 40. Now clearly this can be reduced. Both of these have a common factor of 4. So I'm going to divide by 4 on top, 4 on the bottom, and that gives us 3/10. All right, we're going to continue on with this method, multiplying straight across. 6 times 7 is 42. 14 times 10 is 140. All right, so we got this thing to reduce now. Well, they're both even. Let's just start there. That says 21 over 70. Looks like 7 divides into both of these, so we'll do 21 divided by 7 and 70 divided by 7. That gives us 3/10. Your turn, number 3, multiplying 10/18 by 6/15. So we get 60 over 270. And now we're going to have to reduce this. Notice we have a 0 on the end of both of these. That means we can divide the top and bottom by 10, and that just takes off the 0. So now we're down to 6 over 27, and then each of these is divisible by 3. So we'll divide by 3 and get 2 over 9. So you can see we can get some results that require quite a bit of work to simplify. And in some cases, this can be easier to simplify first because we'll be working with smaller numbers. So we'll look at that next. Here's an example of a problem that can be reduced first. As you can see, the first fraction is reducible. 8 over 12, divide the top and bottom by 4, and that is going to turn into 2/3. Now we've got 2/3 times 5/9, multiplying 10 over 27. So we have no common factors between the numerator and the denominator, and that's the final answer. Your turn, number 4. Here the second fraction can be reduced. Divide the top and bottom by 6. That's going to give us 2/3. So this reduces to 2/7 times 2/3. Multiplying straight across now, we got 4 on top and 21 on the bottom. 4/21. Now in this case, neither of these fractions can be reduced. However, we do have a common factor between the numerator of this one and the denominator of this one. It's perfectly acceptable to reduce across fractions. Because what we're doing is we're dividing a top number by something and the bottom number by the same thing. So we'll get the same answer. So we can divide these by 2, and that gives us 1/3 times 2/7. Multiply, and we get 2 over 21. Your turn, number 5. Six 11s times 4 9s. So 4 9s can't be reduced. 6 11s cannot be reduced. But 6 over 9 can. Dividing by 3, we get a 2 here and a 3 here. 2 times 4 gives us 8. 11 times 3 is 33. 8 over 33. Now there will be times when more than one cancellation is possible. If we look across these fractions, 7 and 14 have a common factor of 7. 6 and 10 have a common factor of 2. All right, so I'm dividing these two by 7 and these two by 2. So that gives us 3 on top here, 2 on the bottom, times 1 on top and 5 on the bottom. And multiplying, we get 3/10. Your turn, number 6. 10/18 times 6/15. Now with this one, you can do it one of two different ways. You can reduce this fraction and also reduce this fraction. I don't know if that's going to get us all the way there. But we can definitely reduce across fractions diagonally. Let's try that. Common factor of 5 here, so I'm going to divide by 5. Alright, sometimes it's easier just to set up the fractions like that. Alright, now we're going to do 15 divided by 5. Alright, so we got these, now we'll do these. We'll do 6 divided by 6. We have a common factor of 6, and 18 divided by 6. Alright, 10 divided by 5 is 2. 18 divided by 6 is 3. 6 divided by 6 is 1. 15 divided by 5 is 3. Multiplying, we get 2/9. Now, if we had just done the individual fractions, and we could take a 2 out of here, that gives us 5/9 times, and then over here, divide by 3 to get 2 over 5. But then we've got one more cancellation to do here. So it'll be one more step, but that's another way to do it as well. Well, sometimes, despite our best efforts to simplify first, can't get rid of all the common factors. So it'll be another simplification to do at the end. All right, I'm going to do these. These have a common factor of 6. So we got 12 divided by 6 here, and 30 divided by 6 here. All right, now these have a common factor of 5, so we got 25 divided by 5, and 35 divided by 5. 12 divided by 6 is 2. We got 5 here, 30 divided by 6, that's another 5. Okay, so just like we saw on the second version of the last example, we end up with common factor on the top and the bottom. So those are going to cancel, leaving us with just 1 over 1. And so we get 2/7. So always check that last answer. We could have just multiplied this across and gotten 10 over 35. Then you got to check that answer to see if it's simplifiable. Here is pretty obvious that we can simplify that one. Your turn, number 7. (16 over 24 times 18 over 40). So with these, 40 and 16, 8 divides evenly into both of those. So we do 16 divided by 8, and 40 divided by 8. And then for 18 and 24, those are both divisible by 6. So this turns into 2, 4, 3, and 5. All right, so looking at this, we have one fraction here that can be simplified. 2 over 4, that turns into 1/2. So we got 1/2 times 3/5, and that is 3/10. Now we can apply this technique to any number of fractions. We'll do as many as 3. Now look for any opportunity to reduce. All right, here we got a 5 and a 10, so common factor of 5 there. And here we have 8 and 12, so common factor of 4 there. 8 divided by 4 is 2. 12 divided by 4 is 3. That gives us 3 down here. Now 5 divided by 5 is 1. 10 divided by 5 is 1, or is 2. And then we got 3 up here. Now we've got two more cancellations we can make. We got a 2 on top, 2 on the bottom, 3 on top, 3 on the bottom, multiplied out, 1/7. And that brings us to your turn number 8. So looking for some cancellations here, we got 3 opportunities here. We have 5 and 10. All right, divide those by 5. We get a 1 here and a 2 here. And we also have 9 and 3. You can divide by 3 here. 9 divided by 3 is 3. 3 divided by 3 is 1. And finally, we have 8 and 4. Divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. All right, and then we can cancel here. Everything else is 1, and we get 3. We get some bigger numbers on this one, but we are going to get rid of those. All right, so look through these, look for any common factors. Anytime we got these repeating digits, we know we can divide by 11. So we got 44 divided by 11 and 77 divided by 11. So that takes care of those two. Now we do 45 and 75. Those are both divisible by 15. All right, so we got 45 divided by 15, 75 divided by 15. And then finally 8 and 12. Those are both divisible by 4. All right, so there's all our Simplifying operations, now we will, 4 there, 45 divided by 15 is 3, so 4/3 for the first fraction. And next one, 75 divided by 15 is 5. 8 divided by 4 is 2. And 12 divided by 4 is 3. And 77 divided by 11 is 7. So now after that simplifying step, much easier numbers to work with here. All right, we've got matching 3's. Those are going to cancel. 4 over 2 turns into 2 over 1. So multiplying straight across, we got 2 times 5 times 1. And that is 10. And then we have 1 times 7. 10 sevens. Your turn. (16 over 21 times 9 over 24 times 35 over 25. All right, let's see what common factors we have. Looks like 8 will divide evenly into 16 and 24. All right, there's that one. Now here it looks like we have a common factor of 3. So we'll do 21 divided by 3 and 9 divided by 3. And then finally here we got 2 that are divisible by 5. So 35 divided by 5 and 25 divided by 5. That gives us 2 sevenths, 3 eighths. Oh, wait, hang on, what am I doing here? 3/3. That's an 8. That makes 3/3, okay. And then 7/5. All right, the 3's cancel. They're gone. 7's cancel. What are we left with? 2 on top. And 5 on the bottom. 2/5. And we can also multiply whole numbers by fractions. Keeping in mind that any whole number can be written over 1. So that's the first thing we're going to do is change that to a fraction. 4 over 1 times 2 over 7. And then just multiply straight across like we did before. 4 times 2 is 8. 1 times 7 is 7. 8 sevens. Your turn. Alright, so change the whole number to a fraction over 1. Multiply straight across, you get 18 on top, 11 on the bottom. 18 elevenths. Now some of these can be simplified before we start as well, or before we multiply. So we're going to multiply 8 times 3 over 28. All right, 8 over 1. And then we can simplify those by dividing by 2. So it gives us 4 over 1 times 3 over 14. Looks like we could have simplified more. I should have divided by 4. Well, we'll have to do it one more time. So we'll divide these by 2 again. That gives us 2 over 1 times 3 over 7, or 6 sevenths. Your turn. 6 times 5 over 21. change the 6 to 6 over 1. Then we get a common factor of 3. So we'll divide by 3 here to get 2 over 1. And divide by 3 here to get 7. So 5 over 7. Multiply it out, we get 10 sevenths. Alright, now we're going to include some mixed numbers. So I mentioned last time that when trying to decide between whether using a mixed number or an improper fraction, mixed numbers are best for answers to word problems, and improper fractions are best for calculations. So the first thing we're going to do when we do any operation with a mixed number is to change those mixed numbers to improper fraction. All right, so we'll do 2 times 4 is 8, plus 3 is 11, so this is 11 fourths. So we get 5 over 11 times 11 over 4. All right, now we're going to multiply straight across, but we have a cancellation here. So 11's cancel, turn into 1s, 5 times 1 on top, 4 times 1 on the bottom. 5 fourths. Your turn. 1 1/9 times 4 fifths. All right, change this to an improper fraction. 1 times 9 is 9, plus 1 is 10. Now we've got a 10 and a 5, so we can reduce those. Divide by 5 to get 2 over 9 times 4 over 1. Multiply it across, and we get 8 ninths. Now some of these will have 2 mixed numbers, so I'll have to change them both. 4 2/3 times 3 1/4. So for the first one, 4 times 3 is 12, plus 2 is 14. So that is 14 thirds. Times 3 times 4 is 12, plus 1 is 13. That is 13 quarters. We can reduce here. We have 14 and 4, those are both even. So divide by 2 and we get 7 thirds times 13 halves. Multiplying straight across, at 91 sixths. Now if it doesn't ask you to change it back to a mixed number, you can leave it as 91 sixths. It's not in the instructions, so just leave it. Your turn. 11 2/3 times 3 3/7. First one, 11 times 3 is 33, plus 2 is 35. Denominator stays the same, so we got 35 thirds. Here we got 3 times 7 is 21, plus 3 is 24. Now we've got some reducing here. We got 24 and 3, that will reduce. Divide by 3, we got 1 here and 8 here. And in this case, divide by 7 to get 1 here and 5 here. So I'll multiply straight across. 5 times 8 is 40. 1 times 1 is 1. So that's 40 over 1, which we can just write as 40. All right, applications. So first one, a couple owns 152 acres of land. They found that 3/8 of the land is swamp and cannot be built upon. How many acres of land can be built on? All right, so there's our picture. We've got the area that can be built upon, and we've got the swamp. All right, so if we want to find 3/8 of something, we multiply. So we're going to take 152 acres and multiply by 3/8. And that will tell us how many acres of this plot of land are swamp. All right, now we're going to change this to 152 over 1. And I'm going to check to see if 152 is divisible by something here. Might be divisible by 8. All right, 8 goes into 15 one time. Subtract to get 7. Bring down the 2. 8 goes into 72 9 times. And that's even division there, so 19. So if we do 152 divided by 8, we get 19 here. 8 divided by 8 gives us 1. So this is 19 over 1 times 3 over 1 after simplifying. Now we just have to multiply straight across. So multiply across on the top. It gives us 57 over 1, which is 57. So we have 57 acres. And at this point, we have to be very careful about describing what we just found. So the biggest mistake I see at this point is people just saying, I got 57 acres can be built upon. That's it. No, that's incorrect. Because what we just found was the area of the land that's swamp, and swamp cannot be built upon. So we just found the size of this, which is 57 acres. But we're not interested in that. We're interested in this part. We don't know how much can be built upon. So we want the difference between the total amount and the swamp acreage. And difference means subtraction. So we're going to do 152 minus 57. Borrowing, 12 minus 7 is 5. 14 minus 5 is 9. So 95 acres can be built upon. All right, make sure you remember the 3 parts to your answer: number, units, and what we're talking about. Next up, funfetti cake. All right, we've got the ingredients here for 4 servings: 2 1/4 cups flour, 4 eggs, 3/4 cups rainbow sprinkles. So let's first find out how much we need for the test recipe or the test batch for 1 person. All right, there's our ingredients. Now we're going to make enough for 1 person. So that is a 1/4 batch. All right, the number of people goes on top of the fraction, and the number of servings that the recipe is originally made for goes on the bottom. So we're multiplying by 1/4. Now for the flour, we're going to multiply by 2 1/4 cups. So we'll change this to a mixed number. 2 times 4 is 8, plus 1 is 9. So that's 9/4. Multiply it out, and we get 9 over 16 cups. So 9/16 of a cup. Next up, we'll 1/4 times 4 eggs. That's 1/4 times 4/1. The 4's canceled, we'll be turning into 1, so that's 1 egg we need. Now do 1/4 times 3/4 of a cup of rainbow sprinkles, and it gives us 9/16. And we don't have to do anything to, just multiply straight across. 9/16 cups of, I'm going to abbreviate RS for rainbow sprinkles. Alright, so that's how much of each ingredient, and that's how much we need of each ingredient for the batch for 1. Okay, so chef tries it out, says, looks good, we're going to make it for 50 people. So let's first figure out how many batches are required to serve 50 people. So we have, each batch serves 4 people. So what we're going to do is take the whole group of people and divide by 4. And we'll just leave it as 54ths. No need to turn it into a mixed number because we're going to be doing operations with this. So we have to leave it as an improper fraction. Unless, of course, the question asks for a mixed number, in which case we better go ahead and switch it out. So 50 divided by 4, got 1 here, subtract get 1, 10. That gives us 2 here, 8, 2, 12, remainder 2. 12 remainder 2, which is 12, and 2/4, which is 12 1/2. So 54ths are 12 1/2 cups. Sorry, not cups, servings. Alright, so for a group of 50 people, we need 54ths servings, or otherwise known as 12 1/2 servings. So let's figure out now how much of each ingredient is required to serve all the people at the wedding reception. Alright, so we'll take the amount we need for each serving, multiply by the number of servings, and it'll give us the amount. So we'll start with flour. Alright, so we need 54th servings. Actually, I'm going to go ahead and reduce this first. 54th is this, we divide by 2, we get 25 over 2. So we might as well just use that number. Alright, so we're going to take that, the number of servings, and multiply that by 2 1/4 cups. And we've already seen that 2 1/4 cups is 9/4. We already did that conversion, so I'm not going to do it again. Looks like we have no common factors. 25, these are just 5s here, and these are 3s. We have all 2s on the bottom, so there's going to be nothing to cancel. So 25 times 9 is 225, and 8 on the bottom. Alright, so that's how much flour we need. But as you can see, that's not a very meaningful number, so let's turn that into a mixed number for our final answer. So 225 divided by 8. Alright, 8 goes into 22 2 times. That's 16, subtract to get 6. Bring down the 5. 8 will go into 65 8 times. 8 times 8 is 64, subtract to get 1. So we get 28. 1 is the numerator, that's our remainder. And the denominator is 8. So we need 28 1/8 cups of flour. So a little over 28 cups. So a lot more meaningful answer here than here. Next up, eggs. I'm going to use the original 54ths instead of the 25 halves here. Because we're multiplying by 4 eggs, so that's 4/1, and we get that cancellation there. 4/4, those are gone. So we need 50 eggs. And finally, rainbow sprinkles. I'm going to go back to 25 over 2 for the number of servings. Alright, so 25 over 2 servings, and each serving requires 3/4 cups rainbow sprinkles. All right, no common factors between the top and the bottom, so we can just go ahead and multiply. And that's 75/8. And now let's convert that to a mixed number. So do 75 divided by 8. 8's going to go into 75 9 times. 9 times 9 is 72. Alright, so 9 is the whole number. The remainder is 3. And the denominator is 8. So we've got 9 and 3/8 cups rainbow sprinkles. Alright, so these techniques are a great way to either cut a fraction or cut a recipe down or increase it for a larger party.